Hello, everyone. As you've heard, I'm Joanne Berger-Sweeney, currently president of Trinity College in Hartford, Connecticut. So I want to begin this talk as David Copperfield by Charles Dickens began. Whether I shall turn out to be the heroine of my own life, or whether that station will be held by anybody else, these next several slides must show. Or,
Best to start at the beginning, and all you do is follow the yellow brick road.
or, as Glinda, the Good Witch of the South, shared with Dorothy in The Wizard of Oz, it's always best to start at the beginning. And so I'll tell you a little bit about my beginnings, becoming a scientist, my own laboratory, and then my transition to administration before concluding. I was born in Los Angeles. I loved skateboarding, beaches, my family, movies. Oh my goodness, I loved movies, and I loved especially musicals. My family was supported, placed a very high value on education, and encouraged my budding career as a science. And from the early age, everyone just assumed I would become a doctor. And I guess I did, but maybe a different kind. My mother thought that it would be very cool if her smart, unconventional daughter from Los Angeles attended one of the 7 sister women's colleges on the East Coast. Now, this may seem conventional to you, but not for a black girl from Los Angeles in the mid-1970s. So, I guess I had a bit of my father's sense of adventure. And at the age of 16, I flew cross-country to attend Wellesley College. I had never been to the state of Massachusetts before I got off the plane to matriculate at Wellesley College. Now, life isn't always easy, and things don't always go as planned. Sometimes you need to figure out how to get back up when you are knocked off your feet. You see, in November of my first year at Wellesley, my mother died unexpectedly of an aneurysm at the age of 46, and I was 17 years old and 3,000 miles from home. My mother, Arminta Parks Sweeney, was a rock star. She had a master's in sociology from Atlanta University, and she was the executive director of the Angeles Girl Scout Council. But also, she was the most supportive mom you can imagine. Now, with her death, which was devastating for me, Wellesley surrounded me like a mother and supported me through a very difficult time. But my mother had instilled in me that I could be anything I wanted to be, and I could do anything I wanted. And despite a D in my first chemistry course and my first year at college, I was not going to be deterred from being a scientist. Now, that was a bit of a rough start at Wellesley, but I did plug along and get back on my feet, and I found my passion. But I was indeed a very lucky girl. You see, my sophomore year, Wellesley hired this young, enthusiastic assistant professor in the biology department to teach in this emerging field called psychobiology. And he was the biology half. This professor, Howard Eichenbaum, talked really fast, especially for a Californian. And he was smart as heck, and he wanted to figure out how memory worked, and his enthusiasm was infectious. This girl's imagination was captured. And as an undergraduate, I was infused with liberal arts values. developing skills of communication, critical and analytical thinking, leadership, teamwork, and a deep sense of civic responsibility. Now, in liberal arts education, breadth is as important as depth, and it leads you to bringing together ideas that nobody ever thought of bringing together before. It's about empowering and mentorship, and you know that people really care about you and your development. And I had the opportunity to do hands-on experiments as an undergraduate. And I still remember what happens when you stimulate the hypothalamus of a live animal. Think about it for any of you who are behavioral biologists. I was a solid B student. I wasn't an academic superstar, but I graduated in the first full class of psychobiology majors because I was willing to try something new and interdisciplinary. I wonder how many people in the audience now ended up as scientists from liberal arts backgrounds. After my undergraduate years, I went back to California and completed a master's in public health and environmental health sciences at UC Berkeley. After Berkeley, I worked at an environmental engineering firm and consulted for several years. Now, people told me, don't start working, you will never go back to graduate school. But I wasn't going to be conventional. And working outside of the academy, those were some of the best years in my life, since most of my career has been in academia. But then, after 3 full-time years of work, I decided to go back and do a doctorate at Johns Hopkins in a newly formed program in neurotoxicology, the study of poisons that affect the brain. And it was combining a bit of my undergraduate background in psychobiology, neuroscience, with my master's field of environmental toxicology. My first rotation at Hopkins wasn't the best. I struggled with some of the medical school courses, and my first rotation advisor told me that I might consider doing something else. In other words, not being a scientist. Okay, at that time, I could not run the perfect gel. But I didn't listen, and I just found a new advisor. My second rotation, I got lucky. My second rotation was on the Homewood campus of Johns Hopkins in the Department of Psychology with Gary Wink and David Olton. And that summer rotation led to my first publication in neuroscience. But in addition to that, I actually had fun in doing the work. And you can see it started my focus on the cholinergic system and memory and neuropharmacology. And that continued to be a theme of my research for 25 years. But more importantly, I was beginning to learn the principles of good science and expecting the unexpected result. So, on becoming a scientist, I got very, very lucky. My third and final rotation was in the laboratory of Dr. Joseph Coyle, who was the head of the child psychiatry department, and he had appointments in neuroscience, public health, toxicology, pharmacology. Yes, he was a bit of a wunderkind. And here, I started to see an important pattern. You know, we scientists look for patterns, and I found out that great scientists can also be great human beings. In Joe Coyle's laboratory, I met great human beings who worked competitively and cooperatively. Our weekly lab meetings were critical thinking experiments for everyone. We got insights into various projects, and we were pushing each other to excel. I learned the difference between hypothesis-driven science and descriptive science, and the importance of each in a particular situation. And in Joe's lab, I had the opportunity to work with one of the most creative and caring mentors, Christine Homan, who was a postdoc in the laboratory. We continued to probe the cholinergic system, this time primarily in development, and how cholinergic dysfunction could be involved in conditions as diverse as Down syndrome and Alzheimer's disease. But remember, this was the 1980s. Don't take the knowledge that you have in 2020 to judge. So, let me tell you a little bit about the science as well as the scientist. In the mid-1980s, there was some evidence that the cholinergic system was involved in Alzheimer's disease. But it was not by any means an accepted theory that manipulating the cholinergic system would have any effects on the course of the disease. I had been working in Joe Coyle's lab making small, discrete lesions of the basal forebrain. And so these are the projections here of the basal forebrain that provide the primary cholinergic innervation of neocortex and here of hippocampus. So maybe I should take a moment here to talk a little bit about modeling a human disease in non-humans. You need to think about what aspect of the disease you want to model: the behavior, the neurochemistry, the neuroanatomy, or the genetics, because it's possible that different models will serve you well in those different areas. So at that time, we were beginning to understand acetylcholine as a neuromodulator. And in fact, as a neuromodulator, it modified the excitatory or inhibitory effects of the primary neurotransmitter. So we called these small, discrete lesions of the basal forebrain, which interrupted the cholinergic system in the cortex and hippocampus, we said that mimicked or modeled aspects of Alzheimer's disease. And we also knew at that time that these small basal forebrain lesions caused changes in behavior, specifically working memory. And we knew that there were working memory or short-term memory changes associated with Alzheimer's disease. So in Joe Coyle's lab, I had found the perfect lab to merge my interests in behavior, pharmacology, toxicology, and the cholinergic system. So I ended up staying in Joe Coyle's lab. Now, here as a little side note, we will talk about the cholinergic life cycle. Acetylcholine is formed from choline acetyltransferase, this enzyme here forming acetylcholine. It is degraded by acetylcholinesterase in the postsynaptic or in the synaptic terminal, and it interacts postsynaptically with nicotinic and muscarinic receptors. And so when Bonnie Davis came and approached Joe Coyle to test the effects of a long-acting acetylcholinesterase inhibitor, which we hypothesized would boost the cholinergic function as a treatment for Alzheimer's disease, we had the animal model in which to test this new drug. Now, to get to the punchline, this drug, galantamine, is a selective, competitive, reversible, long-acting cholinesterase inhibitor. And it also stimulates nicotinic receptors. It turned out to be effective clinically, and it was approved by the FDA in 2001 and is still being used to treat individuals with Alzheimer's disease. Now, back for a little bit of background. As you can see, the clinical formula of galantamine, which went through a couple of name changes, galantamine, and also it is known pharmaceutically as Razidine. And for a number of years, it was the second most widely prescribed Alzheimer's drug in the world. It may seem obvious right now that cholinesterase inhibitors improve cognitive function in some Alzheimer's patients, but it was certainly not easy to publish papers at that time about the cholinergic system and Alzheimer's disease. In fact, I remember we had a paper rejected from Science because it didn't support the plaques and tangles theory of Alzheimer's disease. But 924 clinical trials and 7,740 papers between the 1980s and 2020s, the majority of studies indicate that cholinesterase inhibitors induce an improvement in cognitive function scales in mild to moderate Alzheimer's disease. So, whether it was a cure for Alzheimer's disease or not, it certainly helped millions and millions and millions of people. But imagine back. I was a second-year graduate student, and you get this little white vial of powder, and you have to figure out how much do you use? What do you dissolve it in? What dose is appropriate? Do you have a good model of Alzheimer's disease? So those experiments looking at the effects, the dose-response curve, and medicinal chemistry related to different subgroups being changed and trying to find effective doses and effective drugs for Alzheimer's disease was what I did as a graduate student. And as a graduate student, I had 4 papers between 1988 and 1991 showing that galantamine was effective in reversing the deficits in after basal forebrain lesions. And that was the proof of concept that this drug could work in animal models, and those early animal experiences and the strong will of Bonnie Davis, who had the patent for galantamine, were critical in moving the drug through the pharmaceutical medicine machine and, as I said, become a clinically relevant treatment. But if you ask me whether my scientific work is basic, I would say not always. Is it translational? And I would respond sometimes. If you asked me if it had an impact, I would say absolutely yes. Now, a second theme of my dissertation work was going to have also a long influence on my career. And those were discussions with Christine Homan, who said to me, Joanne, you know, the genome of the mouse is being mapped. If I were you, and given your interest in behavioral neuroscience, I would focus on mouse behavior rather than rat behavior. And hence, I became a mouse behavioral neuroscientist. And it led to one of my favorite titles in my scientific repertoire, which is Mice Are Not Little Rats, with Karen Frick. But I'm jumping a little ahead of myself. While in Joe's laboratory, I met another postdoc, Laure Ory-Levollet, who was a native Parisian. She convinced me that I wanted to do a postdoc in France. Now, many people were telling me I shouldn't do a postdoc in Europe because it would be difficult to come back to the U.S. But I really wanted to live in Paris. I told you how much I loved musicals, and who wouldn't want to live in Paris after watching Gene Kelly and Leslie Caron, dance around Paris, and so off to Paris I went. But heeding some of the advice that I had received, I negotiated up front with the laboratory that I would need to come back to the SFN meeting each year to maintain my contacts in neuroscience and be a part of the U.S. American science routine. It was an unconventional choice to go to Paris, but one that was thoughtful. I had a wonderful life in Paris. I fell in love. I did some good science in Paris in the laboratory of Dr. Yvon Lamour. And yes, that does mean love in French. I continued to work on the cholinergic system, this time the cells of the medial septum which project to the hippocampus. And I used in vivo electrophysiology techniques to understand the bursting patterns of these cells with the generous support of my mentor there, Marie-Hélène Basson, who was a much better electrophysiologist than I would ever be. And as a side note, it is also good to find out what you are not great at as to understand what you do well. And after 2 years and my postdoc in Paris, I saw an ad in Science magazine for an assistant professorship at Wellesley College, my alma mater. And it was the position that Howard Eichenbaum was vacating. He was leaving to go someplace else. So at that time in 1991, I interviewed at 2 Research One universities, an Ivy League university, a major pharmaceutical company, and I liked the people that I interviewed with at Wellesley College the most. I knew I could do world-class science there because Howard Eichenbaum had done so, and I thought it offered me an appropriate work-life balance. So in 1991, I went back to Wellesley College, and believe it or not, Howard helped me negotiate my startup package as he was leaving to go to UNC Chapel Hill. He was a mentor through and through. Now, at Wellesley, 6 months after arriving, I got married to my life partner, Horace Berger, who is here, and we have 2 wonderful children, Clara, who's now 26, and Thomas, who's 23. I loved science, but I wanted a full, well-rounded life. Now, in the 1990s, women were told, sometimes, that you weren't supposed to have children, at least if you were serious about research. And never, ever bring your children to a scientific meeting. But I did. And so a little bit back to my science at Wellesley. As a faculty member, I understood that I had chosen to pursue a career at Wellesley College and that I would need to devote time to my students because it wasn't a Research One university. And I realized that to succeed, I would need to integrate my teaching and research as much as I possibly could. I recognized that Alzheimer's disease was not really conducive to research at a small liberal arts college. It was too competitive, required too many resources, and moved at a pace that I was not likely to be able to keep up. But I had a strategic advantage at a liberal arts college, and that was a lot of smart, enthusiastic undergraduate students. And animal per diem costs were considered as part of the overhead. Those were 2 important factors, especially if you're interested in behavioral neuroscience, which is very labor-intensive and very animal-intensive. I wanted to continue my focus on the cholinergic system, learning and memory, and of course, mice, though I would do an occasional experiment in rats. I knew that to continue to do cutting-edge research, I was going to have to rely on collaborators outside of Wellesley College. But back to Wellesley College. As I mentioned, I had an amazing resource, undergraduate students, and let me share a few that passed through my doors. The first student who came to work in my laboratory at Wellesley College was Beth Buffalo. Others, and you can see, she's a pretty prominent neuroscientist right now. Others who came to the laboratory and through, or that I had interactions with, Ann Churchland, Dorothy Jones Davis, Laura Shavitz, Darlene Gabot, and far too many amazing women scientists than I can mention here. And this is a case when your students are smarter than the professor. And that's okay. For all of you professors out there, it's okay if your students are smarter than you are. But a little bit more about the science. In 1992, shortly after my return to Wellesley, Doug Lappy and Ron Wiley approached me with a new tool that they had developed. It was an immunotoxin which could target specifically cholinergic cells of the basal forebrain. Other toxins that I'd worked with as a graduate student damaged both cholinergic and non-cholinergic cells in the basal forebrain. And here was an opportunity to target cholinergic cells and test the hypothesis of whether the memory impairments were associated with the lesions to the cholinergic system or more general neuronal loss. Working with Stefan Heckers, I, who is a brilliant neuroanatomist as well as neurologist, I hypothesized that the loss of the cholinergic system was critical to the memory deficits. But you know what? I was wrong. And at that time, it was big news that the cholinergic system, when damaged alone, could not induce the kinds of behavioral deficits that we had seen before. It was not critical and it was not sufficient to induce the memory losses that I had documented previously. And so here, 3 years, and with this unconventional choice of doing science at a small liberal arts college, I had a publication in the Journal of Neuroscience. This discovery, along with others, led to successfully receiving an NSF Young Investigator Award, and my unconventional choice in science was paying off. But I also want to mention here a very special trio, Mark Baxter and Karen Frick. Mark was a graduate student at UNC Chapel Hill at the time and was interested in this IgG sapperin research that we were doing. And Karen Frick was my first postdoc at Wellesley College. They had both come from David Oldham's lab at Johns Hopkins, and yes, science is a little bit incestuous, but we had a great time together. And what you will see here is a picture of a marathon basal forebrain surgery session where we were keeping track of how many animals we did. And as you know, Karen Frick is now a distinguished professor of neuroscience, and she is at the University of Wisconsin. So, another aspect of my research that I will share, and it was very advantageous for me to think about studying Rett syndrome. Around the year 2000, separately, Huda Zogby and Adrian Bird discovered the gene associated with Rett syndrome, which is a genetic disease affecting primarily girls. But what was critical for me was in 2003, Rudolf Janisch, the renowned geneticist at MIT, created a mouse model in which this gene, MECP2, was deleted, and he was describing it as a mouse model for Rett syndrome. Now, I had published papers as a graduate student suggesting that the cholinergic losses in development modeled Down syndrome and Rett syndrome, but here was an opportunity to test the hypothesis. Rett syndrome is a rare developmental disorder in girls. And I thought at the time that working in the Rett field was less crowded than Alzheimer's disease and the learning and memory field, and I had a chance to do important work even at a small liberal arts college. Now I'm going to take a little bit of a sidetrack and tell you about a story of persistence. I read about this Rett mouse model in Nature magazine, just like everybody else did. I had developed this expertise in mouse behavior and decided that maybe this was a niche for me. So I first sent an email to Rudolf Janisch proposing that I behaviorally test his MECP2 mice. I sent numerous emails for 3 months. I just couldn't get through to him. He was simply too busy. But I was very nice to his assistant every time I called. And eventually, she called me and she said, I am going to make this meeting happen. And when I got Rudolf Janisch on the phone, he could not have been nicer. He agreed immediately to give me 4 to 6 breeding pairs of these MECP2 mice. And this was a different era. He put the mice in containers in a taxi cab and shipped them between MIT and Wellesley, which was about a 30-minute cab ride. I'm not kidding you. But this left me with an incredibly precious resource, MECP2 mice, and that was the foundation of my colony for the next 10 years. And we published about 20 manuscripts on Rett syndrome, pharmacology interventions, how to improve behavior, neurochemistry, and neuroanatomy. I was at the right place at the right time with the right skill set and some persistence. At this point, most people would say my work was translational, but I contend that I was constantly reading and thinking about basic mechanisms. But it's clear when you study a disease, you can't have a narrow focus. There were cholinergic deficits, but I needed to understand a lot of aspects of brain development, metabolic regulation, as well as respiratory functions in the Rett field. I became a more broad-based neuroscientist, providing evidence, reformulating hypotheses, describing what I found, and when it didn't fit my hypothesis. Now, throughout my career in neuroscience, people were telling me, specialize, 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 become an expert in a very narrow field. But I guessed, as a liberal arts background person, I thought there's a value of generalization in a hyper-specialized world. Now, back for a moment to the people and structures that helped make my career. Dr. Jim Townsell and Joe Martinez and our summers at MBL, where I taught science manuscript writing in the summer to young neuroscience graduate students. This was the quality of scientists that I got to hang out with. They loved science and they cared deeply about creating a stronger, more diverse future for neuroscience. And for me, it was also a family affair. Without the support of my husband and kids, I couldn't have spent long hours in the laboratory, dragged them all over the world to scientific meetings and sabbaticals in Zurich and Edinburgh. My last sabbatical was with Richard Morris in Edinburgh. Joe Coyle continued to support and mentor me. I continued to have collaborations with Christine Homan, and the other piece that was quite important in my background was the Society for Neuroscience. As an associate professor at Wellesley, I ran the training program for diversity in neuroscience. I then came on to council. I was treasurer for SFN, and I believe the first Black person to be an officer in the Society for Neuroscience, but certainly not the last. I served as chair of the Professional Development Committee. I served on the Committee of Committees, nominating other people to committees. So if you're on a committee, I might have put you there. And currently, I serve on the Gruber Selection Committee for the Society. My association with SFN has given to me as much in development opportunities, I know, as I have given service to SFN. So in 2014, I left the bench full-time to pursue an administrative career because of a desire for a broader impact. It was an unconventional choice to leave the bench and become a full-time administrator. I did retain a laboratory, but I was no longer a full-time researcher. One of the reasons that I decided to move into administration was I saw so few black women, because Wellesley's a women's college, in my classes, and I wondered what I could do to change that and how I might make the institution better, not just my lab better. I saw administration as a way to innovate, create, push my agenda of excellence forward at a faster pace. I was in administration at Wellesley College and then became Dean of the School of Arts and Sciences at Tufts. And my fabulous postdoc, Laura Shavitz, came with me from Wellesley to Tufts. And just pointing out, Laura is now Senior Vice President and Head of Research at Recursion. But I'm also going to point out, notice me, I'm on the top steps, and all those students are on the bottom steps. I don't know. It was just tall people who wanted to work in my laboratory at Tufts. It was kind of crazy. But my skills as a scientist were, in fact, very helpful in becoming an administrator. It was an ability to analyze a problem deeply, base my decisions on research and data, experiment, try something new, and see if it works. And also analyzing nonverbal behaviors. Remember, I watched a lot of rodent behavior, and I had to infer the meaning. So I just transferred that skill set from little mice swimming around to humans. Now, when you think of leadership, I don't know, what kinds of words, come to mind for you? It might be strength, it might be power. I will tell you what leadership feels like.
Some people like to climb mountains. I like to build planes in the air.
I grew up wanting to be on a wing, wanting to be up this high.
Sometimes the temperature up at altitude will reach 60 below. It's brisk, it's refreshing.
You never know what you're going to come across up here. Canadian geese, mallards,
owls. These people back here, that's why I come to work. That's why I build airplanes in the sky.
We're not just building a plane here. We're building a dream.
I love this job.
I love this job. It is never boring. It's sometimes frustrating and often satisfying. Now, in 2014, I became the president of Trinity College, one of the premier liberal arts institutions in the country, and located in the capital city of Hartford, Connecticut. I'd found my home and the opportunity to shape undergraduate education. We have a small and strong master's program. Yes, we have a master's in neuroscience, and also we have an engineering program. But we're all focused on preparing bold, independent thinkers to lead transformative lives. I like to say about administration, it is not about having power, it's about taking responsibility. And so I want to share with you what success looks like to me in my current role. It means smart, engaged student body who are bold, independent thinkers. It means more engaged, community-oriented faculty and staff who help shape those transformative lives. And these are 39 faculty members that we have hired in the last 3 years, which is almost a third of our faculty. And we've been able to increase faculty of color at Trinity by 14 percentage points in the last 3 years. It also means focusing on student success. 6 months after graduation, 96% of the students in the class of 2022 knew what their next step was going to be: employment, graduate education, or fellowships. Success also means, I'm sorry to say it, balanced budgets. That's something that you have to think about as an administrator. And also for me, it has been extending our connections beyond our campus into the city of Hartford. And with that comes a little bit of recognition. I was called a top women's business leader in the state of Connecticut. I currently serve as chair of the board of Hartford Healthcare, which is the largest outpatient and hospital system in the state of Connecticut. I got elected to the American Academy of Arts and Sciences, and you can see a few other rather famous people in my class, like Tom Hanks and Barack Obama and Sonia Sotomayor. And yeah, I created that picture with them. We're not all really standing there together. Sorry, folks. And, you know, what I would like to say is, obviously, I believe in getting involved, in trying to make a change from the inside, and I have had extraordinary opportunities. I've tried to live out the Wellesley College motto of women who will make a difference in the world. In conclusion, mine is a story of science, but I hope that you will see it is a story of scientists and people who influenced and shaped me, befriended me, and who were my promoters. Am I the heroine of my own life, as David Copperfield might ask, or am I standing on the shoulders of giants? For all of you young and aspiring neuroscientists, you need to be the heroine or hero of your own stories. And I promise you that your story will be amazing and inspirational. And as Oscar Wilde said, be yourself, because everybody else is taken. And here are a few of the lessons that I have learned. Your mentors don't have to look like you. They do need to care about you and promote you. They need to open doors and networks to support you. As a Black woman, I probably had a harder time in gaining respect, but you just keep plugging away. Administration isn't about power, it's about responsibility. So please, all of you in the academy, be kind to your administrators. We work very hard and we care a lot about what we do. Generalization has its advantages, and most importantly, help others along the way. As much as I have enjoyed my career in the laboratory, I recognized that I needed to do more to be satisfied. I had the possibility to do more, and I seized some of those opportunities to move beyond the bench. And I was prepared to move beyond the bench because I had taken on progressively more responsibility as part of my scientific career, including here at the Society for Neuroscience. I felt that I could innovate, create, and yes, disrupt more as an administrator. And quite honestly, I felt that my science already had made an impact when I moved away from the bench. Who could guess that a little Black girl from Los Angeles would end up as president of one of the most prestigious liberal arts colleges in the country? Well, you have to dream big, and your route might not be conventional. As Ellen Johnson Sirleaf reminds me, if your dreams don't scare you, they're not big enough. And I'm sorry for all the fabulous people with whom I worked that I didn't mention here. And as I end most of my communications at Trinity College, onward, and thank you. Thank you.
Wonderful. So I'm Beth Buffalo, and it's my honor to moderate this session. So I'll be reading some questions. So if you have more, please feel free to enter them into the app. And I'll just say first, thank you so much for a wonderful talk. And I'm so grateful that I had the chance to work with you. And you definitely made a difference, I can say, for me and many, many other scientists.
Thank you.
So the first question we have is, many of us teach and do our research in large R1 institutions. Do you have advice about how we could create a liberal arts style experience for our undergrads, even within a large institution?
Right. Well, I think if you are at a large institution, and particularly if you have a research lab at a large institution, you can certainly create a liberal arts experience for those individuals who are in your laboratory. So that is one way to do it. You can also, within your department, determine if you can serve as a mentor and once again form a small group of people to be able to expand their ideas, answer their questions outside of just the scientific realm. That's one way to do it.
Okay, the next question we have is, throughout your journey, you were able to incorporate things you wanted for your life, Paris, raising a family, etc., which requires self-advocacy. What challenges did you face when setting boundaries and advocating for yourself, and what advice would you give?
So I might say that I am small but stubborn. Sometimes you just need to do what you need to do. It does require a bit of self-confidence, and I continue to tell people I think that came from my upbringing. My mother would whisper in my ear every morning. I am not kidding you. She did not think I should wake up to an alarm clock. She would lean over and say, "You can be anything you want to be." And so, despite, as I said, losing her in my first year as an undergraduate, not doing well in my first chemistry course, having various roadblocks, there was always this little voice in the back of my head saying, "You can be anything you want to be." And what I like to remind people is, are you saying that to somebody else? Maybe someone did that for you. Maybe you just learned somehow in your life that you had to advocate for yourself. But you can also help others by reminding them to advocate for themselves and to do what they want to do. I remember also, I will share a story, when I was thinking about going back to Wellesley College, I knew it was an unconventional choice, particularly given my background, coming from Research One, Johns Hopkins University. And I remember calling up Joe Coyle and saying, should I go to this liberal arts college? Is that way too unconventional? And he said, I'll be at Harvard. That's not too far from Wellesley. If that's what you want to do, that's what you should do. And so sometimes it's also surrounding yourself with people who will support and promote you. If there is someone who is just leaving negative energy around you, it's probably time to walk away.
Great. Okay, the next question is, what are the biggest institutional barriers to rigorous science? And what are the biggest barriers we must overcome to achieving diversity in the faculty? And these are really hard questions. And how do you overcome those institutional barriers?
Right. Okay, so you may have to read those questions to me one by one. I think the first had to do with doing rigorous science. So, unlike, I think, when I was coming through graduate school, now there are incredible opportunities as you are training in neuroscience to study ethics as well as how to do good science. You can find great things on YouTube, folks. It's not all the interactions that you have with people one-on-one. But what you have to remember as you are going through your scientific career is you have to wake up every morning and look yourself in the mirror, which means that you have to be performing science ethically. And I think when you start there, you can go incredibly far. What are the barriers to doing that? Some people feel under pressure, especially nowadays, the people who have thousands of articles. It's probably hard to maintain scientific control and quality if all you care about is the volume of publications that you have. So what you have to decide is that you will be responsible for those things that you will put your name on. And if you do that, you are much more likely to maintain a high quality for your research. And also, what I try and tell people when I was interviewing as an administrator is the people who would come and interview, whether it was at Wellesley College or Trinity College or Tufts University, to get to the point where I was interviewing them, they were very, very good. I worked at very, very good institutions, but the question is it the right institution and is it the right match for you? So sometimes you pass up opportunities that may appear to be great opportunities for somebody else, but it might not be the right match for you. You might need to have a little patience, but if you do, you are more than likely to come up with what is the best fit for you. Many of the people that I have seen not get tenure at an institution, it is because it is not the right match for that person and that institution. They don't like to teach. It's a teaching institution. They don't like to do research. You need to do teaching and research. But whatever, you will be much happier if you find the place that fits your interests, your needs, and your skill set, and not just a place that someone else tells you is highly prestigious.
Great, thank you.
Oh, did you ask also about barriers to diversity?
I did, yes.
Okay, that is and will continue to be a challenge, but I have to tell you, just walking around the Society for Neuroscience, if I could tell you how much it has changed in the last 30 plus years that I've been in the field, somebody is paying attention to diversity. Somebody is making sure that the generation behind us is much more diverse than the generation in which I started way back in the 1980s. So whatever the barriers have been, we have been overcoming them. And this is one of those times where I have to say, each new generation is standing on the shoulders of the giants that did the work before them. As I showed you, Joe Martinez, Jim Townsend, I saw Ann Etkin. These are the people who cared so deeply about ensuring the next generation of neuroscientists looked different and we're more diverse than the previous. And when I look at the officers in the Society for Neuroscience, the people who are running the programs now, I know that the work that we have done has made a difference.
Dr.
That's it.
Berger-Sweeney, thank you
I get
so
to
much.
stand down.
A wonderful
Thank
tale
you.
of bidirectional mentorship.
Thank you. Thank you, Alex.